Oh, we already got 5 people in here. 4 people in here. Now they're all leaving now that I'm talking. Oh, and Kyle's first. Hey, Kyle, you want a big job? Cool. Boom. There you go. I just gave you a big job. I'm going to get started in a couple of minutes. I'm just trying to get set up and give people an opportunity to come into the live stream. It's not required that people have to be here for the live stream, obviously, since the video will be available after the fact. And I will, after the video is published, I will include timestamps so that if people need to go back and rewatch something or just watch a certain portion of it, they don't have to go through all of this talking at the beginning. They can just go straight there. Let's see. I'm just getting all of my ducks in a row. Actually, yeah, you can actually, Kyle, put people in like kind of like a timeout or something like that. It's really weird. Whatever. So it says that I have 8 people watching now. Just yes, I do. Settlers of Catan. We have the junior edition and the adult version as well. My son loves playing the junior version. He is 5 and he can win it without help. It's just crazy. But anyway, why do you ask? I'm assuming you play it or something along those lines. No, your brother probably. Yep, there it is. Yeah, literally, I called it right before you typed it. Yeah, Settlers of Catan is a fantastic game. And he would be right. Um, yeah, we fall into a similar personality type. So obviously it says we have 9 people watching now, just for the sake of argument. I mean, I see Kyle and I see Rachel. Anyone else present? You don't have to comment if you don't want to. Oh, look, there's Matt. You don't have to comment if you don't want to. But obviously, if you have any questions in the middle of this lesson, please, by all means, I can see the chat live while I'm filming this. So, oh goodness, why am I coughing so much? Don't answer that. But if you have any questions, you can obviously ask during the live stream itself. While you're here, click that like button. And no, I'm not going to assume that, Kyle. Shut up, Kyle. I'm going to take away your moderator powers. But oh, there's Mackenzie. But yeah, click that like button, and and there's some kind of a notification thing. I'm not really sure where that. Oh, if you like subscribe, yeah, there it is. If you like subscribe and then click that notification thing, you'll get live reminders or whatever that I'm live streaming or posted a video or something. Obviously, some of these videos will be for you, Algebra 2 students. Some of them will be for my AP Stat kids, and some of them will be for my discrete students as well. But yeah, by all means. Now, I mean, for those of you that are here, now I got 10 watching. That's awesome. But I'm about to get started in a moment. So, oh, I got a knock at my door. There you go. Hold on one second. Let me go see what that knock was. There we go. Oh, goodness. Yeah, so I am live streaming in my bedroom because I have two young kids that are running around doing whatever they do. A 5-year-old who's supposed to be getting kindergarten lessons, and now he's playing his ukulele in the other room. And a 1-year-old, soon to be 2-year-old, doing Lord knows what. It's been quite an adventure. So I'm going to ask you guys the same question that I asked my AP Stat students when I gave their first live stream lesson. And that is, on a scale of 1 to 10, can you give me two numbers on a scale of 1 to 10? 10 being the worst, being the level to which you were bored every day during school compared to the level of boredness that you've been feeling the last couple of weeks. So on a scale of 1 to 10, the level of boredness that you felt in school versus the level of boredness that you felt in the past 2 weeks. I'll give you a moment to post that in the chat. Here, I'll move this out of the way. 6 and 10. Yeah, 5 versus 10 for 6 to 7, that's not bad. No, most people have been like near like an 8 and 9 and 10. God, really, Kyle? You've gotten less bored. Oh, there's Emily. Yeah. I don't know. It's been an adjustment. Except for Kyle. Kyle's weird. No. I'm I hope he does. Anyway. Okay. I'm gonna get started. So I know you've all missed this. I know you've all missed the moment that I would be saying this verbally. But if you do not already have them out, I'm gonna need those notebooks out and open. You know what? I said, there we go. This is the beginning of chapter 8. You know what? I don't want to use this one. I'm going to use actual paper. I'm going to use actual paper because I want to keep these. Ah, she missed that. People have missed school way more than I don't know. Anyway, so I'm beginning the lesson on chapter 8. Obvious. He did not. I'm starting the lessons on chapter 8, but obviously chapter 7 with exponentials, you just wrap that up with your projects. Hopefully you've wrapped that up with your projects. Your projects, of course, are due tomorrow. You've had several weeks to get them done. And yeah, if you have any questions, email me about that. But this chapter 8, I'm going to be combining a couple of lessons. This is going to be simplifying rational expressions. Let me show you the end result of this chapter. The first couple lessons here are just going to be focusing on simplifying rational expressions, simplifying weird kind of looking things using factoring, which is why I posted that factoring video the other day. But the end result of this, and you might be able to see this better on my calculator than your calculator, if you have a calculator. The TI-83s do these a little bit differently. But ultimately, you might end up with something like this. I'm going to explain what a rational function is in a little bit. Some random junk like that. Now, it doesn't matter what the equation is. Let me insert a square there. There we go. Doesn't matter what the equation is. What matters is what they generally look like. There's a nice one. If you can kind of cry over that, this is a typical rational expression graph that we will eventually be able to do. I'm going to show you various ways that you can get this done at home without a graphing calculator. You don't need a graphing calculator in order to get this particular thing done. But I am going to show you the various things that I would expect of you. Anywho's, let's start with something. Let's start with something kind of basic like this. Just an example problem that I'm just going to show you where this thing is kind of going. So let's start with something like x squared plus x minus 12 divided by, let me make sure that this number works out correctly. There it is, x squared minus x minus 20. That works for me. Now, the directions on a problem like this would be to simplify. And the thing that you have to realize, first and foremost, you cannot just cancel out the x squareds. You cannot just cancel out the x's. You cannot just simplify 12 over 20. You can't do any of that. The reason why you can't do any of that is because each of these expressions are in kind of an invisible set of parentheses. You cannot just simplify them down because what has to happen is the parentheses would have to be evaluated first, then division could potentially take place. But right now, you cannot just cancel these, simplify these. You can't do it. So instead, the procedure that you guys are going to follow when it comes to simplifying these rational expressions, you are going to have to factor. You need to factor the numerator by itself. You need to factor the denominator by itself. Now, that's why I spent that video the other day, and I'll probably repost that link in a little bit, but I spent that a long time going over, or it was like a half an hour, going over just factoring, Tucker method, factoring. That's why you had an assignment last week that had you describe your issues with factoring and what different questions you may have had in regards to the Tucker method of factoring. We need to be on top of factoring in order to do this process. Now, for the sake of argument, this top expression, I'm going to have to factor this by itself. You could go through the Tucker method if you wanted to separately. You could do a times c, negative 12, two magic numbers. I won't ask for people to give answers in the chat because there might be a little bit of a delay. But for the sake of argument, the two magic numbers here would be positive 4 and negative 3. You could do a t-chart, and it would factor into the following expression. Just the top of the fraction. See, Kyle's jumping in with those numbers. But that's just the top of the fraction. Again, they're not asking for you to solve it. We're not there yet. That would be the end of the chapter. They're not asking for you to do anything other than just factor it out, see what happens. Now I look at the bottom of this fraction. The bottom of this fraction, clearly not the same expression, clearly not the same factors per se, but we need to find again the two magic numbers. A times c gave you negative 20. Your two magic numbers in this case would be negative 5 and positive 4, because they would add up to negative 1, the b value, and they would multiply to negative 20. Negative 5 and positive 4. Now, I throw out a rhetorical question because, again, I know that people are going to answer in the chat, people are not going to answer in the chat, whatever. But one thing that you should absolutely notice is the fact that there is an x plus 4 on top and an x plus 4 on bottom. That is key, that is vital, that is so important to simplifying these rational expressions. Because, as always, once we have everything being separated by multiplication and division, now we can go ahead and do what we want to do. Usually, we were not allowed to distribute an exponent because there was addition subtraction. Usually, we weren't allowed to do anything with like a square root because there was addition subtraction, separating terms on the inside. But now, there's nothing more than multiplication and division separating all of these terms. There's 4 terms, technically. There's an x plus 1, there's an x minus 3, there's an x minus 5, there's an x plus 4. Because of multiplication division, I am allowed to cancel out these 2 terms. X plus 4 divided by x plus 4 would just simply cancel each other out. Or they would just divide to become 1. What I'm left with is x minus 3 over x minus 5. You cannot simplify any farther. You can't. Before I said that you can't just cancel out these x squareds, you can't just cancel out these x's. The same rule applies over here. You cannot just cancel out those x's. There are imaginary parentheses around the top and the bottom. You would have to evaluate the parentheses first, then do the division, order of operations. That's simplified. That's all you can do to the problem, to this particular problem. Now, some of you may look at this and be like, okay, I kind of get this. Factoring, Tucker method, whatever. I'm just going to drop out of the stream now and hopefully I'll watch the video a little bit later. No! Ask your questions now. Give me those views. I found out that in order to be monetized, I need to have 4,000 hours of watch time. And in the past couple of weeks, I think I've gotten almost 200 hours. Only 200 hours out of 4,000 that I need. Whatever. We'll get there. We'll get there. Let's try another one. Let's try another one. Matt, where have you been? Why do you think people call them cycle? Anyway, let's try another one. I do have my textbook open now. Some of you may or may not have brought your textbook home with you. Whatever. But we'll figure this out. Let's try another one. Let's try... That's a decent one. Let's try this one. Because I'm going to be using some of those factoring steps from the Tucker method that I reminded you of in that other video. And I would strongly suggest that if you're still uncertain about the Tucker method, that you go back and watch that video. It's a short video. Oh, Matt. Why would you call him Kevin? Anyway, so I'm looking at this problem. And again, the goal is to simplify. When you look at this problem, you cannot just cancel stuff out top to bottom. There are parentheses, there's addition, subtraction going on here. You have to factor. Your first step, as was chapter 4, as was chapter 5, your first step is to factor. This is why we've been hyping factoring all year long. So, I look at the numerator, just the top of the fraction, just the top of the fraction. And I think to myself, okay, I have to go through the Tucker method. Step 1 of the Tucker method. Can somebody type into the chat what step 1 of the Tucker method was? As quickly as possible. I pause for dramatic effect. What's step 1 of the Tucker method? Nobody wants to say it now. It's just like class. It's like I gotta pull teeth. All right, no, no, Kyle. That's step 2. That's step 2 of the Tucker method. Remember, if you go back to the Tucker method, there were 5 main steps. Step 2 was A times C. Then it was magic numbers. Then it was T-chart and simplify. Then it was to write the factored form. But what was that step 1? What was that step 1? There he is. GCF. You need to remember GCF, as Matt just said 3 times in a row. 4 times. Well, that's Kyle now. He's trying to make up for it. If you look at the first 2 terms here, there's no C value, there's no like plus number, but it's a cubic, it's not a quadratic. Weird. But they both have a variable in common. They both have an x squared in common. Because they both have that x squared in common, you can take that x squared out as a GCF. If you divide the first term by x squared, taking it out, you're left with an x. If you divide the second term, you get, well, minus 9. Now, that's just the top of the fraction. See, the thing is with the Tucker method, sometimes if you take out that GCF as a first term, sometimes if you take that GCF out, you're done. Again, I showed this in that review video from last week. We took out that GCF. We don't have a quadratic here anymore. This is linear. We're done with the top of the fraction. Let's go to the bottom of the fraction. Now, the bottom of the fraction, you can go through the Tucker method. Take out a GCF. GCF is 1. Skip it. Step 2, a times c, negative 54. You can write these little notes out to the side if you want to. When we get to more advanced problems, I am going to do that. I'm going to write out little notes to the side. Maybe we'll do that next. But in the bottom of this fraction, a times c is negative 54. Negative 54. I have to find two magic numbers that multiply to negative 54, and at the exact same moment, they add up to negative 3. It's like a 9 and a 6. But the 9 has to be negative. Negative 9 plus 6 gives you that negative 3. A negative 9 and a positive 6. For these problems, you don't really have to do the t-chart because of the 1x squared. But this is good for now. We have completely factored the top. We have completely factored the bottom. This is the key. Look at that. Factored, factored. Boom. Everything's being separated by multiplication division. Mr. Markey, can we now cancel out the x minus 9s? Yes, you can. You can. The x minus 9s cancel each other out. You're left with x squared over x plus 6. There is nothing else you can do. Do not try to simplify the last couple of x's. You can't. There are parentheses around that. This is the simplified form. Eventually, like I said, later on in this chapter, we're going to be graphing these. Later on in this chapter, we're going to be solving equations involving these. It's going to be phenomenal. Can you feel it? I can. You probably can't, but I can. Hopefully it's palpable. Let me see if I can find a slightly weirder example. Slightly weird example. I'm actually looking at my textbook right now. Yeah, that's a perfect one. Let's do this one. Kind of change it up just a little bit, because the first few examples that I've been using have involved factoring. The following problem, you actually won't have to factor, and I'll explain why in a moment. But first, let's write this one down. Write this one down very carefully. 14 xy squared z cubed over, at this point, some of you are checking out, 21 w to the fourth x squared y z. Some of you are regretting waking up this early. Look, I already lost a few people in the chat. I can see it right there. That's funny. 7w xyz. Mr. Morgan, I did not wake up to to deal with stuff like this. And I see what you're saying in the chat, though, but trust me when I say that this problem is 1,000 times easier than you think. 12w squared y cubed z. That's the problem. Now, again, notice my z's. I don't want you to confuse my z's with 2's, so I put that little line through it so that you know it's a z. No, you cannot leave for lunch now. No. Actually, you know what? This would actually be the exact time that you guys would leave for lunch. That is an emoji I have never seen before. That's fun. Anyway, this problem. This is a rational function. By the way, do you ever wonder why they call them rational functions? They are rational functions because they are ratios. They are fractions. They're nothing more than functions or expressions that just form a fraction. That's it. Now, I want you to notice something. The first few problems I walked you through factoring. The reason why is because the first few problems had the addition-subtraction issue. Things were being separated by addition-subtraction, and you had to assume parentheses around the top and the bottom of the fraction. Now, you can think this to yourself, see if you can get this one right, kind of just a rhetorical-ish question. What is separating all of these terms in the top and bottom of the fraction? What is separating all of these terms in the top and bottom of the fraction? It's nothing more than multiplication and division. There is no addition and subtraction. None. Kyle just said it, multiplication, division. That's the only thing that's separating everything. I left this problem on top, this other example that we just did. I left this problem on top to show you this. The reason why we could begin canceling this junk out is because everything was separated by multiplication and division. The second that you can get everything to be multiplication and division, you can start canceling junk out like that. Whereas down here, it's already multiplication division. We can start canceling junk out. I have no idea what that emoji is. I'm not even going to ask. Anywho. No. For example, I'm going to point to a couple things and then I'm going to start crossing stuff out. I'm going to do this very slowly. I get an x and I get an x. They're being multiplied on the top of the fraction. Because they're being multiplied on the top of the fraction, on the top of the fraction, on the numerator, you should be getting an x squared. Now look at the bottom of the fraction. On the bottom of the fraction, you only have an x squared. Now this doesn't always happen. I'm going to deal with this a piece at a time. But these two x's, first you would multiply the top of the fraction. Yeah, x times x gets you x squared. And then on the bottom, there's an x squared. The logical thing to do is, well, I believe they would cancel each other out. What about the rest of them? Now, hold on. I'm not writing anything just yet. I'm not crossing anything out just yet. I'm kind of leading to a conclusion. Let's look at the y's. I got a y squared over here. I got a y over here. If I multiplied them together, I would get a y cubed. Now, let's look at the bottom of the fraction. Oh, look, there's another y cubed right there. I guess they would cancel each other out. But this other y right here, it would still be there. The one that I'm pointing to. There's a lot of things going on here. There's a lot of moving parts. There's 4 different variables, and there are constants as well, or I should say coefficients. Let me show you a strategy. The strategy that I want to show you is just simply put this. First, I'm going to leave it as 14 times 7. I don't feel like multiplying them together. I do not feel like multiplying them together and getting, what, 98? No. Let's just leave it like that temporarily, and let's just see what happens. This is just the top of the fraction. On the top of the fraction, I have an x times an x, and I get an x squared. Okay. On the top of the fraction, I have a y squared and a y. That just gets me y cubed. On the top of the fraction, I have a z cubed and I have a z. Again, all being multiplied together, that gets me a z to the 4th. Now, I still have a w up there. That w is still a variable. That's a w to the 1st power. I'm just going to put that at the end right there. It's just a w to the 1st power. That takes care of the top of the fraction. Now, we're not done yet. We're not nearly done yet. I'm showing you a strategy. Let's look at the bottom of the fraction. I don't feel like multiplying out 21 times 12. So I'm going to leave it as 21 times 12. I'll deal with simplifying those in a little bit. What is 21 times 12 for the sake of argument? It's like, what, 252. I don't feel like dealing with that. And I'm not going to deal with that. So just leave it be. Let's look at the x's. On the bottom of the fraction, I only have an x squared. On the bottom of the fraction, it looks like I have a y to the fourth power when I multiply them together. On the bottom of the fraction, z times z gets me that z squared. And on the bottom of the fraction, ooh, the w's. W to the fourth, W to the second makes W to the sixth. Again, strategy. Now I'm ready to start doing some things. First and foremost, those x squareds definitely cancel each other out. Those x squareds definitely cancel each other out. We'll deal with the numbers in a little bit. Let's look at the y's. I have a y cubed on top, and I have a y to the fourth on bottom. Now think about that. On the top, you have y times y times y, and on the bottom, you have y times y times y times y. That's what you may be asking yourself right now. Why am I even here? But even still, I ask you the simple question. Okay, there's 3 y's being multiplied on top. There's 4 y's being multiplied on bottom. Stuff gets canceled. Let me show you a little side note over here as to what it looks like. I won't do this for all of them. That's what those y's look like. Those 3 y's on the top cancel out those 3 y's on the bottom, leaving you with just the y on the bottom. On the top, it's just a 1. Now, for the sake of argument, that 1's just going to be multiplying and doing nothing. But that's what that thing becomes. Another way of thinking about it is just the idea, and I'm going to kind of walk you through this with the y's. There's 3 y's on top. There's 4 y's on bottom. I could ask the question, who wins? Well, the bottom wins, because they have more. Okay, how many more do they have? 1. Okay. The bottom wins because they have 1 extra y. Look at the resulting simplification. The bottom has a y to the first power. You could do this for any of them. These 3 y's cancel out. This becomes a y to the first. Again, I'll simplify my answer in a moment. Let's look at the z's. Who wins, top or bottom? You would say, oh, the top wins because they have more. Yes. How many more do they have? Well, they have 2 more. Yes. These z's cancel, and these z's become a z to the second. Comparing variables top and bottom, that's typically what happens. You may have learned strategy in the past where you subtract the exponents. Yes, you could subtract the exponents. I'm trying to show you something a little bit more simple. Let's look at the w's. Who wins, top or bottom? You would say the bottom would win. By how many? Oh, it wins by 5. Yeah. This w cancels. This becomes a w to the 5th. Again, I'm going through this slowly. Simply because I want you to see this. This is the first time you may be seeing something like this. Obviously, for future problems, it's going to be a lot quicker. Ah, Chris is here. I don't know, Chris, how did you just get here? Somebody answer that question. You're back in class. Anyway, now the only thing we haven't dealt with are the numbers. We got a 14 and a 7 and a 21 and a 12. Watch this. First of all, 7 and 21. I'm looking at Donovan's comment. I put you on. I'm like, what? Oh yeah, Kyle, as the moderator, figure out where Chris's pass is. He's a half hour late. Anyway, I'm sorry. Back to this. The 7 and the 21 both have a 7 in common. They both have a 7 in common. 7 over 21, temporarily treat it like a little fraction. And the 7 cancels, and the 21 will divide that by 7. You're just left with a 3 there. 7 over 21 simplifies to be 1 over 3. Look at the 14 and the 12. They both have a 2 in common. Divide both by 2. Mind you, there's still a multiplication there. Now, just looking, can I watch this later or no? Of course you can watch this later. This is live stream will be saved, and I will be posting this on the Google Classroom with timestamps. He's Clutch Nation. What do you mean, who is he? You guys don't know who Clutch Nation is? Anyway, back to this. Now, looking at the coefficients, 7, 3 times 6 on the bottom, they have nothing left in common. Nothing left in common. Let's just look at the top of the fraction now. On the top of the fraction, we're left with 7 and a z squared. On the bottom of the fraction, we have a 3 times 6, and we have a y to the first and a w to the fifth. That's all we can do for the problem. Yes, Matt, you can go fill up your water. Just take the 3-hole punch. I got my water. See? Anyway. I'm going to fill that up in a few minutes. This problem is probably one of the more intense problems that you may end up seeing. But I just want you to be aware that these things may be thrown at you. Let's take a look at something else that we could potentially see. Okay. I'm going to get a new piece of paper for this one. Write down the following problem. Let's write down example. 3a squared plus 6a plus 3. I'm going to walk you through every single step of this piece at a time. On the bottom, I got an a squared minus 3a minus 10 divided by 12a squared minus 12 over a squared minus 4. Yes. Now, this is a problem that does take several things into account. It takes kind of what we just tried to do with simplifying the coefficients, and it takes a little bit of the Tucker method of factoring. He's saying, please no again. Again, these are the problems that you're going to be faced with. If you want to know where I'm getting these problems from, in your textbook, page 534. I'm getting them directly from your textbook. These are kind of extreme factoring problems. Alan, yes, they will be here later. Every single thing that I'm going over this video will be saved. And the link will be made available to you guys, and there will be timestamps in the description for you to go back and just double check whatever you need. Absolutely, yes. So you don't have to search through an hour-long video in order to find the one problem or the one explanation that you need. So. But let's see what we can do with this. Now, a couple things. First and foremost, you're dividing fractions. What you may have seen in the past with dividing fractions, what you need to remember about dividing fractions, is that ultimately you can change that division symbol to a multiplication symbol by flipping the second fraction. What's that? Like, there was like a 3-letter thing, I think, like keep, change, flip or something like that, KCF. There it is, KFC, there he is. Kyle knows what I'm talking about. But in this case, yes, we're going to have to do that. We're going to have to change that to multiplication, and we're going to have to flip the second fraction. Absolutely, yes. And we'll deal with that. We'll deal with that in a minute. Let's look at what else we have. You also have to look at this problem as if it were 4 problems in one. There's the 3a squared part of the problem. There is the a squared part of the problem. There's the 12a squared part. And there's the a squared minus 4 part. Yeah, PTSD. That's another letter. Whatever, shut up. But there are 4 parts to this problem. And they still want you to simplify. I don't know when you guys first learned the keep, change, flip thing. I really don't know. That might be like a middle school deal. Like multiplying and dividing fractions. Anyway. We have to deal with this one piece at a time. We do. There's going to be multiple layers of factoring going on here. 5th grade. So, first and foremost, top left of the problem. You have to take out a GCF. You have to take out a greatest common factor. You have to take out a 3. Let's just see what happens when we take that 3 out. There it is. There's a song? Oh, Kyle, sing it. I'm going to let him sing it while I take this GCF out. Now, if you notice, I'm just making a little note for myself up top here where I'm taking the GCF out. I took the GCF out up top. I thought that was a sine, cosine, tangent. You're talking about SOHCAHTOA? Oh, Kyle should definitely make a video of him singing it and send it out to the rest of us. I'm pretty sure as moderator, Kyle, that is your responsibility to do so right now. Anyway, I took out the GCF. The GCF was 3. I had to divide it by all 3. Ooh, a cat in a box. Sorry, these little emojis just get me. Anyway, now I'm still going to have to factor this farther. And if I factor that farther, well, a squared plus 2a plus 1 if you walked through. Ooh, he sent a link. Hold on, I'm going to click on the link. I just want to see what this does. Kyle, you better not be lying to me. Oh, that's funny. Okay, cool. I'm going to watch that later. Gosh. All right, hold on. I'm going to save that video for later. Click. There we go. That's awesome. That's cool. Anyway, I got to get back to math. A squared plus 2a plus 1. If I walk through the Tucker method with that and I did a times c, found my magic numbers, blah, 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 ultimately, it would factor into an a plus 1 times an a plus 1. I'm blah, blah, blahing past the Tucker method because, again, the Tucker method is something that we should have known from way back when. And if you need a reminder and a review on the Tucker method, there is a video available on the live stream for you guys. Oh, I got an email. Anyway, back to this. On the bottom of the fraction, this a squared minus 3a minus 10, if you walked through the Tucker method with that problem, a times c, you get a negative 10, you got to look at your magic numbers, would be negative 5 and positive 2. Where are my kids at? My kids are with my wife right now because my son is technically in school. My wife is a certified kindergarten teacher or elementary school teacher. So she gets the lessons from his teacher, and she's basically walking him through various lessons, inside, outside, just trying to get him moving. But anyway, they're awfully quiet. Too quiet. Okay, so we did the Tucker method to the bottom left. As I mentioned, we're going to have to change this to a multiplication, and we're going to have to flip this junk around in a moment. We will flip that junk around in a moment. But first, I got to take a GCF out of this part of the problem. You can hear them now. Whatever. It's a little creepy, Kyle. But I took a 12 out as a GCF out of this part of the problem. Again, Tucker method, GCF should always be your first step, always be the first thing you look for. The a squared minus 1 can be factored via the Tucker method. And it can be factored into an a minus 1, a plus 1, which I'm going to do in a moment. But I'm going to kind of do two things at once now. The division is being changed to a multiplication. And I'm going to flip the second fraction. So not only am I going to factor it using the Tucker method, but I am going to flip it according to that KFC rule that Kyle keeps talking about in that music video. I should make that music video like homework for you guys. Anyway. Now, since it's been flipped, yes, this a squared minus 4 is going to end up on top, but we also have to factor the a squared minus 4. And again, going back to the Tucker method, if you factored it correctly, it should end up like that. The whole point of this chapter, or this lesson, I should say, is to remind you how to factor things if they need to be factored. If they don't need to be factored, like the previous problem that we did, then so be it. We can begin simplifying junk down. But at this moment, everything in the problem is being separated by multiplication and division. Everything. We can begin simplifying junk down. Now, 1 for 1, they can be canceled. For example, this a plus 1 and this a plus 1 can cancel each other out. Not both of them on top, but only 1 for 1. This a plus 1 and this a plus 1 can cancel each other out. This a plus 2 and this a plus 2 can cancel each other out. This a plus 1 and this a minus 1 cannot cancel. They can't. In order for things to cancel, they have to be exactly the same thing. They have to be exactly the same thing. So they cannot cancel. They remain. Sorry. There is one more thing that can simplify. The 3 over 12. Both can be divided by 3. If you flip, do you have to change it from division to multiplication? Yes. Yes, you do. Technically, that is what happened. This 12 a squared minus 1, I factored it into 12 a minus 1 a plus 1 because of that flip. That flip occurred right here. And if you notice division to multiplication, I tried to make it very clear with that multiplication symbol. And this a squared minus 4, which was on the bottom, now it's on the top. But I factored it into a minus 2, a plus 2. This 3 over 12, both can be divided by 3. And you're left with that. Now, this 1, you can have it there if you want. You don't actually need to have that 1 there, but you can. It's fantastic. But ultimately, the simplified version of this problem, I'm going to look across the top now. You could have that 1, you could not have that 1, it's up to you. Sometimes it's just good to have it in there for the sake of argument, but that's the top of my fraction. You don't have to multiply them back together, you can leave them as is. On the bottom of my fraction, there's a 4 there. I'm probably going to write the 4 first. And you can leave those on the bottom like that. That's all you can do to the problem. Nothing else cancels. This is the simplified version of the problem. This chapter may seem like a lot of work. Once you get the hang of things, once you remind yourself of the factoring that has to take place, you'll be fine. Again, this is why I emphasized the Tucker method of factoring last week. That's why I had you tell me your thoughts on the Tucker method of factoring. That is why I made a video for you to walk you through the Tucker method of factoring again. This is something that we've been doing since November. And it's something that will play a major role in this chapter. If you need help with the Tucker method, either watch that video or send me a message directly asking for a clarification or whatever the heck it is, but watch that video. That video will help you. The factoring quadratics review. I forget what I called it. Well, we'll figure that thing out. Ooh, I have a fun problem. When I say fun problem, you know it's my kind of fun problem, not your kind of fun problem. Let's see here. There we go. Okay, now I'm going to write this out exactly as I have it in the, or exactly as it's written in the textbook. I'm going to write it exactly as it's written in the textbook. So, see the yay? I can. The dots are sarcastic. Anyway, my kind of fun problem. Here's how it's written directly in the textbook. X squared minus 9 over 6x minus 12 divided by x squared plus 10x plus 21 over x squared minus x minus 2. Just double checking to make sure that's written correctly. It is. Kyle, that's your reaction to every single one of these problems. But this is how it's written. Page 534. This is where I'm getting all of my problems from. Just this one page in your textbook. Take a look. Cat in a box. Now, I know you don't like it. No, you're not. You're in. This problem just looks mean. Yeah, you're scared to look, but it just looks scary. It's not actually that scary. It's not that bad. See, the thing is, when you look at a problem like this, you have to recognize the fact that, yes, there's all these extra division bars going on here. But there is one overarching division bar right in the middle. And because of that, you have to assume that it's this fraction being divided by this fraction. If it helps, you could rewrite the entire problem as that fraction with the division symbol that like looks like that. But I'm not going to do that because I want to save myself space and time and money and all that fun stuff. Instead, I'm kind of going to do a few things all at once. But I need you to recognize the fact that this is the main division bar in the problem. So, let's look at the first fraction. The first fraction being the x squared minus 9 over 6x minus 12. The top of that fraction, x squared minus 9, if you walked through the Tucker method, would give you x minus 3, x plus 3. I'm just going to write that over here. On the bottom of the fraction, it's not a quadratic. It's the 6x minus 12 is not a quadratic. But you can take out a GCF of 6. I'm going to take that out. I'm going to divide both terms by 6. I'm going to leave it like that temporarily. Now, this, I'm going to put a little extra step in here. I am going to write it out like this, actually. Divided by. Yes, we have to change that division symbol to multiplication, and we will in a moment. We will in a moment. But I wanted to factor this separately first, and then we'll do that keep, change, flip thing. If I'm looking at this part of the problem, they're asking me to divide by this fraction. Well, let's factor just this top part right here. X squared plus 10x plus 21. Again, walking through the Tucker method, A times C, magic numbers, blah, 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 you can find positive 3 and positive 7. Well, it is almost lunchtime, Matt. Although for some of you, it's probably breakfast. Tell me I'm wrong. Anyway. If I do 3 and 7 for that, I get an x plus 3 and an x plus 7. I'll deal with the keep, change, flip in a moment. Let's look at the bottom of this. X squared minus x minus 2. Magic numbers, -2, +1. Now, don't start canceling stuff out just yet, because as Kyle put in all capital letters, KFC, I don't know, you call it KFC, it's really KCF, but keep, change, flip. You're going to keep this first fraction, you're going to change this to a multiplication, and you're going to flip this fraction over here. So that's exactly what I want to do right now. Keep, change, yeah, you keep saying it's KFC, flip. Once you do that keep, change, flip thing, I probably should use like a dot there for multiplication, because I don't want you to confuse that with a variable, but whatever. It's multiplication. We can start canceling junk out now. This x plus 3 cancels out with this x plus 3. This x minus 2 cancels out with this x minus 2. Nothing else cancels. Nothing else cancels. Ms. Mark, you look 3 and 6. Again, can't do that. That 3 is trapped with the x. It's an x minus 3 that does not cancel out with the 6. Final answer, top of the fraction. Bottom of the fraction. That's all you can do. These problems are not as bad as you think. They just look scary. All that these problems are doing is repeated factoring, 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 canceling, canceling, canceling. That's all that they're doing. Now, you say it's terrifying, but I'm usually right in these things. I pretty much am right, but... And we will get more practice with this. We will get more practice with this. I wanted to show you one more section today, kind of as an intro. I think that's a monkey with a hammer. Not sure where you're getting these things from. But anyway, I wanted to show you one more section of this, because again, we're going to be getting more practice with this as time goes on. I'm going to have various things for you to be able to do. But let's talk a little bit more about this. I'm going to make up a problem right here, just to kind of show you what I'm referring to. There we go. Simplifying rational expressions. Everything that we've done up to this point has been dealing mainly with the operations of multiplication and division. This is a problem where you have two fractions being separated with an addition sign. I'm getting into addition-subtraction. Now, I asked this rhetorically because I'm going to answer it myself in a moment. But try to remember, when I add or subtract fractions, what must be true? You need to have common denominators. You need to have common denominators. See, in all of the problems that I've shown you up until this point, every single problem, and I have them all right here. Watch. Yeah, I had things just being divided. Again, you don't need common denominators. With these problems, you have these two things being multiplied together. No big deal. They're being multiplied, meaning if you're multiplying fractions, top times top, bottom times bottom. Fantastic. Same thing right here. You're dividing these two fractions. Again, division, multiplication, you don't need common denominators. You just multiply top times top, bottom times bottom. Same thing for this problem. Giant fraction. No big deal. When eventually we got done here, it was top times top, bottom times bottom, and we cancel stuff out along the way. But with this problem, you need a common denominator. So I look at my denominators. I have an x and I have an x squared. They are not common. You have to force common denominators. In order to force a common denominator for this particular problem, you're going to need to alter the way that an equation looks. Now, I'm going to write this out the long way, just so you can see it. This is the long way of writing it out. Right here, I have changed the way that the fraction looks. I am multiplying my first fraction by x over x. Technically, I'm just multiplying it by 1. I'm just multiplying it by a 1. That's all I'm doing. Not changing the value, I'm just changing the way it looks, because I'm forcing common denominators. If I do that here, I end up with x over x squared with that little multiplication, plus a 2 over x squared. Now I have common denominators. What you've always been taught about adding and subtracting fractions with common denominators still holds true. It's still true today. If you're adding fractions with the same denominator, the denominator stays the same, and you just simply add the 2 on the top. Get there. You just add the 2 terms on the top. Now it just so happens that the 2 terms on the top, x plus 2 over x squared, well, that's your answer. That's all you can do. That's all you can do to the problem. It's a very weird scenario. It's a very weird scenario. Let me show you an additional one, just like it. Different example. Again, this one's not in the book. I'm just kind of making this one up in a moment. Let's just try a 1 over x plus 2 minus a 2 over x squared plus 3x plus 2. Now this problem is going to be the main focus of today. I mean, obviously we've focused on a lot so far, but this is one of the biggest problems you're going to see today. X plus 2 is linear. X squared plus x squared is quadratic. Common denominator. They're clearly not the same denominator. Here's what you need to do first. Factor. Factoring is still the name of the game. Factoring is still what you need. The Tucker method of factoring quadratics is something that is so vital to this process. That's why I hyped it all last week. As Kyle and Matt are just trying to flex what kind of things they can type into the chat. The rest of us are trying to focus on how to get these answers. Or wondering what we're getting for lunch. If the first thing I have to do is factor, that is exactly what I am going to do. And if you notice, is that Purell? Anyway, you're focusing. Yeah. If you notice, on the bottom right, this quadratic, I factored it into an x plus 2, x plus 1. They both have an x plus 2 in common, these two fractions right here. Now, so one might think, oh, they can cancel each other out, blah, 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 blah. No, don't worry about canceling things out. You can't cancel things out the way that you want to. You can't just cancel things out the way that we did before, because things are being separated by addition, subtraction. What you're going to need to focus on after you factor is you need a common denominator. You need a common denominator. Whenever you are adding and subtracting fractions, you need a common denominator. I keep repeating it because I need you guys to understand that. Adding and subtracting fractions, you need a common denominator. They do not have a common denominator. The first fraction would have a common denominator if that first fraction were multiplied by an x plus 1. So that is exactly what I'm going to do. And I'm actually going to write this in red so you can kind of see me adding it into the problem. If I were to multiply this first fraction by x plus 1 over x plus 1, I'm not changing the value of that fraction. I am not changing the value of that fraction. I am simply multiplying it by a 1. But by doing so, I am forcing the first fraction to have the exact same denominator as the second fraction. In doing so, I can bring them together into a single fraction. Once they have a common denominator, I can bring them together to have a single fraction. My part now is to make sure that the numerator is simplified properly. Now, yes, it's a 1 here. I'm just going to temporarily write that because I'm going to have to simplify and combine like terms here. And it is subtracting the numerator on the other side. I'm going to have to simplify that junk in a moment. Yes, if it's a 1 here, it's not going to do anything, but, you know, just for the sake of argument, if it wasn't a 1, you would have to distribute it. It'd be an x plus 1. An x plus 1 minus 2. X plus 1 minus 2 just results in an x minus 1. And the bottom, well, just stays the same. Ran out of room there. The whole goal of adding and subtracting these fractions is to basically turn them into one of these types of problems where it's nothing more than multiplication division. See if you can simplify stuff and then kind of go from there. We're going to do one more problem together, and then I'm going to call it a day. Not today, because your projects are due tomorrow. But at some point tomorrow, I may be assigning something in regards to this lesson that I just gave you. Now, again, so far it's a 70-minute video, but again, I'm going to have timestamps so that you can bypass all of the fluff in between. So you don't have to watch all 70 minutes in order to get the lesson. You can just simply go to the parts that you need to go to. But I have one more problem that I would like to do today before we sign off. Let's try this one. 8 over x squared minus 6x minus 16 plus 9 over x squared minus 3x minus 40. It's the last problem we're going to do for today. The first thing that you have to do, the first thing you have to realize, I should say, is that, yeah, you're adding fractions together. I'm adding fractions together. I need a common denominator. Clearly, the denominators are not the same. I need to factor. Factoring is usually step number 1 for all of this stuff. Factoring is usually step number 1. That is why you need that Tucker method. If you walked through the Tucker method with this problem, you would have 8 over, well, let's just say x, that'd be like, what, a negative 8 and a positive 2. Plus, the second fraction would be a 9 over What magic numbers would work here? Not 10 and 4, 8 and 5? Yeah, 8 and 5 with the 8 being negative. Nice. Now again, all I've done so far is the Tucker method of factoring to the denominators. You can do it to the numerators if it's even possible to do, but it's not necessary. You just worry about the denominators. You need common denominators. Again, they clearly are not the same denominator. This first fraction does not have an x plus 5. This second fraction does not have an x plus 2. I'll write this in red so you can see what I'm doing here. But basically, I'm forcing common denominators by doing a little multiplication action going on here. This first fraction is missing an x plus 5. This second fraction is missing an x plus 2. If I were to multiply this first fraction by the x plus 5, and if I were to multiply the second fraction by x plus 2, I would force common denominators. And ultimately, I would be able to bring them together into a single fraction with this as my denominator. That's the goal. Now, I still have to simplify junk down, but that would be the goal. Now, if you notice the parentheses that I did here, I am going to have to do a little distribution action here. I am going to, again, that's a positive 9. Mind you, a positive 9. If this were minus, I would have to count it as a negative 9, but it's positive. But I am going to have to do a little distribution action here. This is going to get me an 8x plus 40 plus 9x plus 18. Ugh, looks terrible. Or wonderful. You do not have to multiply the bottom of this fraction back together. You don't. Don't worry about it. Leave it as is. That's a 5. But I have to simplify the numerator. 17x plus 58. Always double check to see if you can factor the top of that fraction. Just for the sake of argument, 58 divided by 17. Can I do that? Nope, can't do it. You can't take out a GCF. Always double check to make sure that you can factor or not factor the top of that fraction. Because in some instances, you may be able to simplify farther. But in this particular instance, that is our answer. That's all we get. Oh, happy day. Haha. Anywho's, this concludes my lesson for the day. Wait, we only have 4 likes. Like our timeout? No, Kyle. Don't force people to like this if they don't want to. I threw a like in there for myself. Anyway. But this concludes the lesson for today. So again, in the timestamps, I am going to put this as the time of, hey, this concludes the lesson. I'm, going to, just talk for the last part of it. Matt's going to go get lunch. Sammy say, please always do these. What, live streams of lessons? I'm assuming that's what she meant. Yeah. Honestly, this is the closest, okay. This is the closest that, I can get to, being in the classroom with you guys again, I have realized that over the past few weeks that what I've been doing now, what I've been doing here. Oh, look. Oh, by the way, look at that. There's indentations on my desk now. Oh man, that sucks. Anyway, but the stuff that I've been doing the past couple weeks has basically been office work, clerical work, keeping track of who has interacted with whatever, like, oh, this person did this assignment, oh, email this person, oh, send this information to this person, blah, blah, blah. That's all I've been doing for the past 2 weeks, and I have been losing my mind. I have been I've been doing live streams with my AP stat class, and my wife, you can thank my wife, she encouraged me to do live streams with all my other classes as well. I was a little skeptical at first because I'm like, well, AP, but I'm like, you know what? No, some of them will be able, you know, like right now, there's only 9 of you. I have 55 Algebra 2 students. 55. And I mean, don't say anybody, don't say names, but you know that there are people that would just like, not watch these videos whatsoever or anything along those lines, or just crap all over just doing like a live stream or something like that. And that's their prerogative. That's totally fine. They don't have to. But my wife was right. There are students who would get a lot out of this. And it would kind of be a little bit of a break from the norm because it, I don't know, like, what have people been doing? Like, some people have still been working, like working jobs and stuff like that. Um, but mostly, like, I don't know. And some of you will probably admit to this, but like some people like wake up at like 11 o'clock in the morning, every day. Like I've been getting up at, 6 and 7 o'clock. 6 and 7 o'clock for me to wake up is late. I'm usually waking up at 5, you know? Oh, gosh. I tell you what I did this weekend. I'll put a link in the description, or in the description. I'm sorry, not in the description. In the chat. What I did this past weekend. I'll copy the link here. There it is. Boom! I participated in an online cubing contest called Cubing at Home, and there were, I gotta see how many there were. There were over 4,000 competitors signed up. It was insane. It was fun. But basically, they had like a Twitch stream and a YouTube stream going at the same time, and they had competitions throughout the day, and you could basically you had to film yourself doing the solves and filming yourself opening up the scrambles and junk like that, and basically like solve it. It was cool. It was fun. See, now I want a cube. That's all. But I've been doing that. I've also been taking up a lot of my time playing with my kids, obviously. For those of you that have been following my Twitter, I have not been posting assignments. I've been posting basically my own, trying to keep myself sane from the day. So every day I'm going to be posting, every weekday I'm going to be posting pictures of myself just trying to stay sane. Some people have been like, oh, it's a nice wake-up call for me when you post those, Mr. Markey. And I'm like, okay. It's like I post them at 10 o'clock. You're waking up at 10 o'clock? Yes, I'm waking up at 10 o'clock. Here, I'll do something nice for you guys. I'll solve this on camera for you. So you can see it's all scrambled. If you're interested, hold on. If you have a cube of your own, let me find the link for my video. If you want to learn how to solve the Rubik's Cube on your own, I am going to put a link in the chat that you can do on your own. It's completely up to you. Paste. Boom. Yeah, I have a half an hour, 38-minute YouTube tutorial on solving the Rubik's Cube, and people have used it in the past for fun. So here, I'll solve this for you guys. I usually average somewhere between 50 and 55 seconds. I'm not actually going to time myself. Hold on, I'll scramble it. There we go. And now I'll actually solve it. So let me just take a look first. The timer doesn't actually start until I actually begin solving it. So, here. Rachel's probably like, I've had enough of this from my brother. We've been stuck inside for this entire time. Oh gosh, that's fun. See, cubing does take away part of the day. You know, it does for those of you that want to learn how to solve it. It's just, it can be worth it. You know, it can totally like just, I don't know. There we go. I don't even know what this time is. I'm probably at like over a minute right now or something like that. Yay, it's solved. Boom. Oh, about to die. Yeah. All right. Yeah. Well, anyway. Yeah, people want to leave and stuff like that. But anyway, yeah, I'm gonna wrap this up. I'm just rambling now because whatever. Anyway, like I said, I'm gonna add timestamps to this. They'll probably be up by this afternoon. And yeah, I'm gonna sign off too. So you guys stay good. Stay tuned to the Google Classroom, and I will of course give you heads up before I do a live stream. See you later.